So here we are going to learn about joining numpy arrays, numpy searching arrays, numpy sorting arrays, how can we filter arrays in numpy, and random numbers in numpy. So let's start with joining numpy arrays. Okay, so joining means putting contents of two or more arrays in a single array. So traditionally in SQL we know that we can join tables based on key, whereas in numpy we can join arrays by access. So we can pass a sequence of arrays that we want to join to the concatenate function along with the access. If the access is not explicitly passed, it is taken as 0. So let's start. So in the first array you can see that okay, I have the 1D array over here, again 1D array, and I just concatenated it, and you can see I got this one. And suppose by default it considers x is equal to 0. Now suppose I specify x is equal to 1 over here. So what happens is like 1, 2, 5, 6. So first dimension gets merged with the first dimension here, and second dimension gets joined with the second dimension here. Now there's another function in array in numpy which is very helpful in joining is a stack function. So stack is same as concatenation. The only difference is that stack is done along a new axis. So we can concatenate two 1D arrays along the second axis, which will result in putting them one over the other, that is stacking. So here you can see that one is getting over at like 1 4, then we are having like this 1 4 2 5 3 6. So if you want to like go specifically inside an array and access element one by one, you can do like this. You can get the very first element from here and very first element from here, then second element from here, second element from here, and similarly for the third and third. And suppose we want to do a stack using rows, so we can use stack function. So this is kind of similar to this one. So these are very common functionality which are very useful, like knowing about these small syntaxes like stack, stack, concatenate, even x role of x is kind of very helpful in dealing with arrays. Now again there is something else like height. How can we stack along height? So we have something like this, array 1 and array 2 and 3, we are getting something like this. Now another thing which I want to talk about is how can we search arrays in numpy. Okay, suppose I have this array. Okay, now I want to search what is 4. Okay, so this gives you the indexes. So this is very important. Like suppose you want to get the index of that particular element. So here I've given np.where. Okay, this name itself kind of resembles that. Okay, it is going to give you the index of that particular element. So here the element is 4. So we can find that okay, 4 exists at 3, then it exists as 5 and 6. So and you can see where you can see the value is stored in this x. Now I need to find the indexes where the values are even. So and this gives you the all the indexes over here, and with this command, and you know this np.where, which gives you the indices. Similar thing for odds. Now suppose you want to sort an array. Of course in list we have this, and traditionally in Python list we have this function about sorting, and here also we can sort with numpy function. So let me run this. So it's sorted. Similarly I want to sort in strings alphabetically. I can do this. Suppose I want to do it for Boolean. This is not important, but still I'm just showing you that even it can work on a boolean values also. Now how can we sort a 2D array? So you can see that it individually it worked. It sorted 324 and 501 with this command. Now I want to filter my array. Okay, so I have this thing about, like, I have 4 elements from here and I just want 41 and 43. So what I did, I passed true false, and here I get only the true values, and you can see I just got this one. Let us go deep inside it. Like, getting some elements out of an existing array and creating a new out of them is called filtering, of course. In NumPy you can filter an array using a boolean index list. A boolean index list is a list of booleans corresponding to indexes in the array. So if the value of the index is true, the element is contained in the filter array, and if the value in that index is false, the element is excluded from the filtered array. So suppose we want an array from 0 and 2, so index 0 and 2. What we did, we wrote true, and then we wrote false for the remaining indexes, and we got the new array over here. Now let's consider something else. In similar manner, so in the above example, of course, we hard coded true and false, and you can, let's assume that if the array is of like is length greater than 10, so are we going to write 10, are we going to assign 10 different true false? Of course it will be time of course will consume a lot of time. So what we can do is, we can run a for loop, and suppose we want, the question says that we return only values which are greater than 42. So we can create an empty list over here, and if an element is greater than 42, we can just append true, and for else we can append false, and we can just do the same. We can just return the indexes which are true. So you can see true, so I got 43 and 44. So suppose create a filter array that will return only even elements from the original array. Same thing over here. If it is divisible by 2, then append true to this empty list, and false for if the number is odd. And similar manner, you can see that false, true, false, true, false, true. So what is this true? 2, 4 and 6. So you can see same thing over here. So here even we don't require I would say true false over here. We can directly make a new variable called array greater than 42 and see it worked. This is the second way of doing it. Same thing over here. So here we are skipping of true and false. We are just writing that command and we are featuring that command inside this. So it becomes array greater than 42 and it gives you the new array. Same thing we did over here. We wrote the condition over here in this filter array and we just passed this filter array over here and we got this one. Now let's talk about random numbers in NumPy. So random number doesn't mean that we will have a different number every time. It means something which cannot be predicted logically. So like if I give you a theoretical background around it, like computer works on programs and programs are definite set of instruction. So it means that there must be an algorithm to generate a random number as well. So if there is a program to generate random number, it can be predicted. Thus it is not truly random. Random number generated through a generation algorithm called pseudo-random. So can we make truly random numbers? Yes. In order to generate a truly random numbers on a computer, we need to get random data from some outside source. The outside sources generally are keystrokes, mouse movement, data or network. So we do not need truly random numbers unless it is related to security. So here in NumPy we have an inbuilt function which generates random numbers on your own. Suppose I want to generate a random number from 0 to 100, so I use this functionality from NumPy. So I just wrote from NumPy import random, and I just want a random integer between 0 to 100. I got this. Suppose I run it again, I got 17. Again I'm running, I'm getting 63. So it is completely random. There's no algorithm or predefined algorithm to find out why it gave you 63. And suppose same thing for, I would say, for float. Every time it is going to be different, it cannot be predicted. And suppose here out of this 100 we need to generate a 1D array which contains 5 random integers from 0 to 100. Again, it has an inbuilt functionality. So here you can see I use an one integer. It gave you one integer over here with the random command. It gave you one random floating number between 0 to 1. Here again I'm getting some random numbers over 100 and I'm giving a parameter size is equal to 5. So it gives you 5 different values between 0 to 100. So I got this. So again I'm running it. This time I'm getting, every time I'm going to get something different. So here suppose again I can specify the size here. So this means we are defining a size, like it is basically a 2D numpy array over here, and you can see 2D array. So every time it is going to be different. Even for float we want 5 different values, so it is going to give you 5 different random values between 0 to 1. Now let's try this. So 2D array with 3 dimensions and 5 elements in each, and again you have something which is common, like okay, out of a given array just pick one random value. So this is just like a Ludo game, so it is all random. So I got 5 this time, I got 9 this time. Let's make it even more. Okay, now let's see. Every time I'm going to get something different. This is purely random.